install some exe file, the exe file will be installed in the operating system there. Okay, so like Windows operating system or Linux operating system. So in Linux also some exe file will not be installed there. Okay, for that we have to take some other procedure. Okay, so wine software is there. Wine is there. By using wine we have to install some software in Linux operating system. Okay, so there are different operating system and their procedure of installing application in that operating system is different. Okay, and user will need to learn how to use the new application. This thing is very mandatory, because suppose you are expert in computer, you know that how to use Google Chrome. Your father is another user, he is suppose novice user. Okay, he is a novice user and he does not know that how to install the operating system. Okay, okay, so the user has to understand that how to use a new application, that thing. If we change the operating system, need to make if we change the operating system, this need to make the sure that both the application and the hardware will be compatible with the new operating system. Okay, so that means that this is telling that when if we want to change the operating system, so can we change the operating system? Yes, that is possible, but we can also keep two operating system in our computer. Okay, three operating system also you can keep in our computer, but that thing is telling here that if we change the operating system in the computer, then whether the operating system is supporting the application or the hardware we have installed there, that should be checked. Okay, so that is the compatibility, actually the application compatibility and the hardware compatibility, that should be checked here. This is the computer architecture where you can see that different devices, different registers are there installed here. CPU is there, and the bridge, that bridge is actually connecting RAM, and then the USB devices are there, keyboard, okay, keyboard and mouse is there. Okay, and then through the ISA port, PCI port and the USB port. USB port is taking either your input devices or output devices, and PCI port is there, that is the COM1 COM2. Okay, I don't know who is calling several times. I cannot allow someone group size calling. Just a minute, I'm trying to join someone. Let them join. So see that these are the IO passes here. So these IO passes are communicating with the computer hardware devices for different tasks to be performed. Okay. Next we have, so they are actually giving the photos here, that is the processor and the RAM. Okay, photos of the processor and RAM they are showing here. The keyboard, mouse, and the network interface card, NIC card. Okay, and then the USB devices like pen drive, etc. This is the webcam, that is also linked with the USB devices or USB port. So this is done. Now the central processing unit, you see that the memory. So if I tell about the computer to work, okay, so which device will work here? That means the processor is the main device, that is the that will perform the processing here. Okay, and it is called the brain of the computer. Okay, so it performs all the calculations. Okay, so all the calculations will be done here by using the central processing unit, CPU. In order to do this job, the CPU needs commands to perform and data to work with. So commands means what? Means a CPU need instructions and data together to work. Okay, the instructions and data travel to and from the CPU on the system bus. So there are three different types of buses. Okay, one is the address bus, the other one is the data bus, and the other one is the control bus. Okay, address bus is only from CPU to memory. Okay, so it is unidirectional, means in one way only, and the data bus is bidirectional, means from CPU to memory and memory to CPU, and control bus is to all the devices. Okay, so what is happening here, how it is controlling, how it is how the data bus and the address buses are working here, because we know that the memory has some address. Okay, so if we want to link or if we want to send some data from CPU to memory, then we have to specify some address there. Therefore the CPU will communicate, or CPU will generate some address, and according to that address the data will be stored. Therefore it is unidirectional from CPU to memory only. But if we are talking about data, data can be transferred from CPU to memory as well as from memory to CPU. Okay, so if we take some data from memory to CPU, then it is possible. Also from CPU to memory it is possible. Okay, so in this way CPU read and CPU write these things. So memory read and memory write, both are possible there. So that is possible by using the data bus. Okay, because this is the bidirectional bus, so both way communication is there. And finally the control bus, this control bus is controlling different operations like read operation, write operation, memory read operation, IO read operation, or IO write operation. So that thing is controlled by the control buses. Okay, also interrupt can be handled here. Okay, that are possible. The operating system provides rules for how that information gets back and forth and how it will be used by the CPU. So operating system know the rules that information, any information that will be how they can be used. Okay, that should be known to the operating system, and how the CPU will use that one, that information, that also will be known to the operating system. So CPU is one important part. It should be there in the computer operating system, in the computer system, to get the task worked. Now the RAM is the primary memory, and RAM is very important part also, because every application or the software like your operating system also, it should be installed in the RAM so that the computer will start. Okay, so there is a program called the bootstrap. So when you are going to start your computer, you are going to reboot your computer, at that time if you have the ROM, in the ROM bootstrap is loaded there. Bootstrap is a program that stores the routine of the boot. Okay, so that boot routine will be loaded from ROM to RAM. Okay, and then your computer will be starting. So instead of starting a TV, if you are going to start computer, that will take much more time. Starting a computer will take much more time than turning on TV. So what is the reason there? The reason is that the pre-works are there, because loading the bootstrap loader from ROM to RAM, that will take time. Then the operating system will load it there in the RAM, and then some other applications that are the prerequisite applications that will be loaded in the RAM. Then your computer will be starting. Okay, so you see that this is like a desk or a workspace where the computer temporarily stores all data and informations and the instructions. Okay, so this particular place, this RAM, is actually taking some temporary data. Like temporary data means why? Because this RAM is a volatile memory. RAM cannot keep some data or instruction for the permanent time. Okay, so when the power will not be there, the RAM will lost everything, every data and the instructions. So therefore it is telling that it is the place where we can only store data information temporarily. Each RAM chip contains millions of address spaces. Okay, so we know that RAM size, while we are increasing the RAM size, the RAM size is increasing in the term that we can get much more faster machine, and many applications can be executed at the same time. Okay, therefore we are using RAM size, I mean huge RAM size, so like your 8 GB RAM size or 4 GB RAM size or 16 GB RAM size, this thing. So that is only why that each RAM chip contains millions of address spaces, and that address spaces will store the data and the instructions by which you have to work. And CPU will face the instructions and their corresponding data to work. Okay. Each address space is the same size. Okay, and has its own unique identifying number called the address. So for the address space in the memory, there is a specific size, and they will be identified by a number that is called the address of the memory. The operating system provides the rules for using these memory spaces and control storage and retrieval of information from RAM. Means when the instructions will be executed by the CPU will take the